Hi, everybody. I'm back to talk about stoichiometry of gases. This is what we are going to end this unit with. So we are almost done with gases. What I wanted to start off with was reviewing with you some of the ways that we can convert our different measurements of amounts of things. So number of moles is in the middle of my little diagram here. And if you recall, when we were talking about the roadmap and converting moles into other things, to mass, to particles, moles was also in the middle of that roadmap. But here we have another branch off of our roadmap. So we're going to just review first the two that we are more comfortable with, that we've seen a little bit more, and then we'll go over and talk about volume. Moles and grams. So when we are converting between moles and grams, we use something called the molar mass or the formula mass, which is the same thing. We find that on the periodic table. So we can convert moles to grams, grams to moles by using that mass. We convert moles to particles or molecules or atoms or ions or any other tiny little thing by using Avogadro's number, which is 6.02 times 10 to the 23rd power. We won't really be using that one here. We'll be focusing primarily on mass and volume, which is our new one. So we use the molar volume of gases to convert between moles and volume. 22.4 liters of a gas at STP is equal to 1 mole of that particular gas. Now, I keep stressing at STP because it's not always the case that 1 mole of a gas is equal to 22.4 liters. It's only at STP. If it's not at STP, then we have to use another way to find the volume or moles given whatever values we're given. So that brings me to our last slide here, our modified roadmap. So we've seen something similar to this in the past with stoichiometry when we're talking about chemical reactions. We're going to continue talking about the stoichiometry of chemical reactions. However, we're going to be focusing on reactions that involve gases or the production of gases. So I put the roadmap here twice just so that we could look at how to go in either direction. So if you are given volume to start with, volume of some gas, your first conversion step is going to be to change volume of that gas, volume A, into moles of that gas, moles of substance A. And there's two ways to do that. If the problem says it's at STP, then we can just use that 22.4 liters as our conversion factor, and it's very simple to set up. However, if it's not at STP, then we have to plug in what we know into the ideal gas law equation and solve for what we don't know. Now, if we're starting with volume and going to moles, what we know is going to be volume and what we don't know is going to be moles. So we would be given pressure and temperature as well in order to solve this particular calculation. Once we get to moles of whatever that substance is, substance A, we use the same mole ratio as we used previously to get to substance B. Remember that mole ratio comes from your balanced chemical equation. And then finally, going from moles of substance B, our new substance, into mass, we use the molar mass of that substance, which we find on the periodic table. So this portion of the roadmap, I would say 3/4 of our roadmap, has not changed. However, we've thrown volume in here at the beginning, and we need to know when to use this conversion factor and when to use the ideal gas law in our calculations here. Now, the other scenario is if you're starting with mass and asked to find volume. So you start with mass of substance A, you would use molar mass to convert that to moles of substance A. Same as before, no different than any of our other stoichiometry calculations. Once you're in moles, you get to moles of your new substance by, again, using that mole ratio from your balanced chemical equation. And then from there, you can go to volume in one of two ways. You can either use 22.4 liters if the problem states that it's at STP, or you use the ideal gas law, plug in the moles, and solve for the volume. And then pressure and temperature would be given to you if that were the situation. We're going to be going over some examples of stoichiometry problems involving gases. So if you have any questions at that point, please feel free to reach out to me. Otherwise, good luck with your calculations.